This one's for you, bud. That's what I should have said. Limit comparison test. Okay. I'm gonna have to delete that. All right. So this is the fourth test in 10.3. Okay, and we kind of mentioned it yesterday when we had a series like this. Our first thought is to do what?
Compare it to 1 over n squared.
Okay. That's a good thought. Which one's bigger or smaller?
Smaller is the one left.
N squared.
Okay, that was two different answers.
N squared.
Oh no, mine is one.
Smaller denominator, bigger number.
For some reason, I
Okay, does that converge or diverge?
diverge.
Converge.
P series converges with P greater than 1, but this is bigger. No conclusion. Okay, so we cannot use the comparison test. Okay, but there's something handy called the limit comparison test. Okay, so here's the limit comparison test. We are going to compare the two in an infinite limit. Okay, so we have the limit as n approaches infinity, and we are going to put the original over the new.
What? Oh.
So we're comparing the two with a limit. It's a limit comparison test.
Then you crop it up with for
Now solve the limit.
so you can cancel the n squares.
So we get a limit of 1, correct?
Yeah.
Would it be negative?
Yeah, be negative.
Why?
Because you have x squared minus 1.
Minus 1 on the bottom.
No, remember, infinite limits, we consider the highest exponent.
Oh,
This
Oh,
strikes
we didn't. We went too far.
way. Yeah, just the highest exponent, so n squared over n squared is 1. Okay, now, if that limit is greater than 0, and 1 over n squared converges, those both are met, correct? 1 is greater than 0, 1 over n squared converges. That implies that 1 over n squared minus 1 converges.
Can the inverse be said?
Okay. That is what we call an if and only if statement. Yes. Do you know what if and only if statement is?
It's
It has to be
specific
that.
case. But then you
I
said
will,
yes.
I will write the theorem down and explain an if and only if statement. If then and
Only then.
inverse both work.
okay.
Okay, so that's one use of the limit comparison test. There are a couple of other conditions that we can look at too. Let me write it down and we'll look at a couple others. So here's the limit comparison test. Okay, it's A sub n and B sub n. Be positive, because we're in the positive section, right? This is 10.3, positive sequences.
Why n squared brackets?
That's how you notate us.
Sequences are sets of numbers.
It's just like an array.
Yeah.
It's a good comparison. Okay.
And we coincidentally found out how to write the code for factorials the other day.
Oh, cool. So we set up a limit, right? And we get an answer of some kind. There are three cases where those can both converge. Okay. If L is 0, so this is an if, L is 0, and B sub n converges. Then A sub n converges as well. This is a direct result of a comparison test. Hunter. If an infinite limit is 0, which one of these is bigger?
It's gonna be the bottom.
The bottom, B sub n, right? So if B sub n is bigger and converges, what happens to the smaller one?
It converges.
Yeah, it's the comparison test, right? That's what this is saying. Okay, so that's why if L is 0, we have this conclusion. Okay. Now if L is infinity, which one has to converge? For the other.
B sub n.
A sub n, because A sub n will be bigger, right?
Oh.
Right.
Because it's infinite. The limit is infinite. So if A sub n converges, then
B sub n diverges.
B sub n converges as well.
Oh,
Because that's telling you A sub n is bigger because the limit is infinite. So if A sub n is bigger and converges, B sub n has to converge as well, right? Okay, so those are two statements. Here's the third.
Writing these sentences would be super weird, but we went back in time and told this to ourselves.
I will never get that far in math. Oh, yes, you will, Marty McFly. All right, here is the last statement that we dealt with the first example. If L is greater than 0. A sub n converges if and only if B sub n converges.
What if L is less than 0?
Just diverge.
then.
Does not
No
necessarily-
conclusion. Do not use the limit comparison test because there's no condition for that.
there's no comparison. Yeah.
All right, what does if and only if mean?
That's the only case it can happen.
No. Think about it in terms of if then. If this is true, then
That has to be true.
this is true. Okay, that's an if then statement, right? What's neat about if and only if statements, they work both directions. If this is true, you can also say, then this is true. It's a double, an if then that works both directions.
Double-edged sword.
Yeah, so if you know, so you get this limit and it's 1. If either of these converges,
Then the other
the
one.
other one does too.
Okay.
Okay, that's the idea.
So B and so A to then B to then are directly related?
Basically, yeah. Okay. Now, if you want a shorthand on this, this is how we mathematicians write that statement.
If and only if is if with 2 F's.
Yeah. That's
Kind
shorthand.
of that's kind of like the question of what the fish is not.
There's your shorthand if you want to keep, I mean, it helps you write less notes, right?
Yeah.
So, if and only if is IFF in shorthand. Do you guys know how to write an if-then statement in shorthand?
IT.
Nope.
That's you.
Let's see which one is. Oh, we could write L greater than 0, B sub n converges, implies, B sub n converges. That's shorthand.
Oh.
Equals the arrow. That's an if-then shorthand.
Nice.
Okay.
See, I just wrote this code, so.
Mathematical notation. Okay, so that's the limit comparison test. You want to take a look at a couple. Let's show. Here's what's nice about this one. They tell you to show that that converges. So you know the answer, you just have to generate the work. So again, I'm going to default to the comparison test because it looks pretty straightforward for that. What would you compare that to?
1 over n squared.
Yeah. Which one?
P series.
Which one's bigger, smaller?
The one on the left is bigger.
This converges. We have a larger. What's our conclusion? No conclusion, okay. So next I'm going to move to the limit comparison test. And I'm going to let you catch up because I'm letting you move fast.
It's 1.
Yep. Therefore,
A sub n converges and B sub n converges.
B sub n converges, so A sub n converges.
that's the limit comparison test. Pretty handy. So I'm going to write this out. Copy dot flip. Okay. So that's the basic gist of the limit comparison test. The next example is very similar.
Should an example, we can go to like some weird hard fault? Just so we have.
Let me see here. There,
You spill it all over the table.
let me see if I assign any of these.
There you go.
39, 40, 140, and 45. 39 is just like this one. 41 is very similar, but has a root in it, so use your root knowledge. 40, very similar. 45, they're all pretty much like this one. Yeah. There are a couple in here that are harder that I didn't assign because it's just not necessary. They're, let's see. Okay, so you'll be fine. There are some problems.
You just wasted that. It was smooshy. I don't care.
You can grab it, it's not there.
No, your hand is always.
We already did the spiraling, right?
Yeah.
Yeah.
Okay. So I'm going to add some others, just so you get practice picking which test to use. Because this is where we start to see in the book how you can choose your test.
Choose your own adventure.
No. I'm stay at home.
Look at me. I look at you. Sure.
Just like you stay there longer.
Yes, reduced pizza.
Reduced pizza.
Yes.
Free reduced pizza.
Yeah. My boy wanted to fix me up. Old price.
Okay, that'll do it.
No.
So those are limit comparison tests. These are any tests.
This is a very large jump.
Okay?
My boy always fix me up.
From maybe 1 to 4. Isn't it? 8 and 12.